Okay, I hope we are recording. So, so what happened is we decided to come give you some insights into how to. I've spoken a couple of times regarding how to get into higher studies and so on, and also get into research and academia, and also research in industry in general. But for that, the area that I would be referring to you all would be artificial intelligence with a special focus on the mathematical side, which is important in much in research, and also the implementation of these algorithms when you'll be doing going further. So this course would be, so I'm also a past pupil of Jadavpur. I completed my BE from the Department of Information Technology in 2021, and so ever since then, I have been in IIC pursuing my PhD. So just a side note regarding that. And then, and also my, so you need to appear for GATE. So I would also be helping you with the material here as well, which will be oriented towards the data science and artificial intelligence program of the new paper that the GATE has come up with. So this course would roughly be structured into two parts. First part would be dealing with mathematical side of AI. So the introductions required or introductory foundations required for you to understand algorithms in machine learning and artificial intelligence. That would be around 10 lectures of 2 hours each for that would be a month or so from now. And then the next 2 months, which would be around 15, 16 sessions, which would also 2 hours each, would be mainly dealing with the algorithms of machine learning. So last time when I taken my course, this course, I had been asked why do we need much probability, some linear algebra, so mathematics you'll do probability and linear algebra. So I will add the description to the previous course here. So in some cases I would be referring to you. So the plan for this is the linear algebra and probability is a vast topics, but I'll be covering them with respect to GATE, as well as required to the level a bit advanced that is required for understanding machine learning from a mathematical standpoint, which would give you an advantage to learn and make algorithms. So I would what I'll do is yeah. So I'm trying to admit people, but it's saying okay. So first few sessions would be on this mathematical side of things, and I'll be urging you all to stay with me and ask questions as when you'll not understand. But these things will be much simpler compared to things that we had done in the previous course. So in case uh, I would skip some things, I may refer you to the videos of the previous course where you can look at more advanced methods of solving things and also more advanced concepts if you are interested in learning more about statistics and linear algebra. So with that, I hope that's a good of an introduction regarding the course. And now I would tell a few, if someone of you, I'll probably say, uh, tell some of my previous students, for example, Brahmojit or Shoptoshi, to maybe talk or tell me how they enjoyed the previous course or what they're expecting from this course, and introduce themselves. And so that after that we can ask some one of the others to introduce themselves, and then if you have any questions, we'll begin within like 8 10 8:15ish and get into the material. So anyone who wants to volunteer to let them introduce themselves and ask some questions or doubts that they have regarding this course. I don't want this to be a monologue. Please share your thoughts. Am I audible, first of all? So I hope I'm audible, right? I've been speaking for quite a long time now.
Yes, you're audible.
Okay, can you be a bit louder, or yeah. I hope everything was clear, right? Hello.
Yes, Manav, that was clear.
Okay.
That's
Okay, so anyone who wants to maybe introduce themselves and tell me what they want like particularly want, or share things like what you want to do, which year are you in, and so on. So somebody is trying to enter the, so it's Ashmit is trying to enter the thing, but I think the person is not being able to enter. I don't know why. Can everyone see?
Actually, it is my other account, so I've entered from the registered ID, so it is fine. You can deny that account.
Okay, sure. Okay. So anyone who wants to share anything, or at least let me know your names and so on, so that I would be easy. It would be easy for me to interact, because anyways we'll not be meeting in the course of this session. So it would be good that we interact to start off with. Okay. So I'll wait for a few minutes,
Nobody.
and then yeah, go ahead.
Okay, so I'll try going first. I'm Siddharth Banerjee. I'm in my third year in my Bachelor's of Information Technology at Jadavpur University.
Okay.
I joined this course because machine learning and AI is something I have a keen interest in, and since I've already appeared in the CSIT paper this year for GATE, I thought I might as well learn a bit about the DA paper, since that's the domain I wish to pursue higher studies in.
Oh, that's great. So maybe yes, you can consider writing the paper for DA next time, once you have some understanding of this. Yeah, great. Anyone else
Yes,
who
absolutely.
likes to? Yeah, that was a great. That is the type of introduction I would like to have from a few more of you. If you are willing, that's a good perspective to have. Okay.
Dada, I am Brahmojit Rai,
Yeah.
currently a second year student in the IT department,
Mm-hmm.
and I had attended your course the previous time, and it had
Okay,
helped
I
me a
know.
lot. And
Yes.
it helps me a lot. And I love math. I love machine learning now, and so that's the reason I'm here. I'm just back and enjoying mathematics.
Great. Great. So anyone else? So we also have a few people from our lab. Yeah, go ahead, Saptarshi.
So I am Saptoshi Ghosh, currently in IT UG2. I also attended
You,
your previous
hmm,
session, but it appeared a bit kind of abstract to me. And in
I
this
see.
session, I'm looking forward to take more on the application of machine learning.
Sure. So last session was mainly dealing with probability, and so that's why you may have thought it was a bit abstract on the abstract side. But as you will see, when you will try to make algorithms, last time I think you were like, yeah, what is happening? I'm a bit confused. Why is this showing? Oof. Okay. Uh, is my screen visible? I hope it is.
Yes, Manakta.
Okay. So I hope, so as Saptoshi was saying, it was a bit abstract. So maybe this time when it is more practical, it will be helpful for you to go back and look at those abstract concepts and see if that reinforces the concepts that you are learning now. So you would, maybe the people who did the course last time, it would be more helpful for them as well. It will be a good standing ground. Others, I am going to, again, I'll be doing all the things that are required to understand machine learning, but there would be some offshoots. I would refer you to my previous course there. So with that, if without further ado, I would begin. So I hope we are recording. So I'll make go to full screen now. Yeah, let me just this the full screen. Great. So I'll begin with firstly, I'll begin with what is, before I get into what is probability, I will get into things like what are numbers, what are ways to count number of permutations and combinations, some things that you have done in your +2 and so on. So I had done this extensively last time, but you may be aware there are two rules in counting theory. Firstly, a multiplication rule and an addition rule. So in case, I'll add the description in case you need the exact definition and so on, you can refer to the previous session. But I hope that these things are they are foundational for class 11-12 as prerequisites. But again, I'll refer to what is a multiplication rule. Can anyone tell me what is a multiplication rule? So say you have a task T and you can complete it in many, say n1 ways, n2 ways, n3 ways. So in way 1, there are n1 ways and n2 ways and so on. So way 3. And independently, you can take any of these ways, way 1 to way n. And each of these ways have n options or something like that. So there are, say, independently, you can do, say, these many tasks. So it is something like, so in case of a multiplication, so you say, I'll give you a concrete example, then it will be much simpler to understand. Say you have a place A and you have a place B and you have a place C, right? So there are, say, 3 roads that connect A and B and 2 roads that connect between B and C, right? So more of a concrete example. So this would be your task 1 and task 2, and you have n1 equal to 3 ways, n2 equal to 2 ways of completing task 1 and task 2. So how many ways? So these are independent. So for example, you need, for reaching C, you need to reach via B, right? So you need to have, so from A to B, there are 3 independent paths, but reaching from A to C is dependent on B. So each of these task steps must be completed in order. T1 to T2 has to be done in order, and each may have any independent number of ways of completing them. So what would be the number of ways you can complete this task?
There are 6 ways.
Correct. So P1, P5, P1, P4, and so on. So you can complete it in 3 ways here and 2 ways over here. So it's 3 into 2 ways of completing it. Similarly, you can also have something called as a addition rule, where you can divide. Say you have a task T, you can divide it into cases, case 1, case 2, and case 3, which are exclusive in nature. And each of them have n1, n2, and n3 ways of completing. So how many ways can task T be completed? Trivially, n1 plus n2 plus n3 ways, right? So they are all independent pathways of completing the task. Unlike here, you had a dependent route of completing this task, but here you have parallel routes. So you can take either of these routes in general. So this is the foundation of a very trivial way of calculating how many ways you can compute things. So for example, I'll start off with a question and then maybe people will get more into it. So for example, the question that we saw this time appeared in GATE asks you, how many ways can you make a 4-digit number of from 1, 3, 4, 6, and 7 such that all digits are divisible by 3? So such that so all digits are unique and the number is divisible by 3. Sorry for that. So the question is, how many 4-digit numbers can you make? So you need to select 4 digits, right? And you have 5 digits available to you. You can select 4 of these digits. And there is a small caveat that you have to, it must be divisible by 3. So anyone if the question was how many 5-digit numbers can you make, what would the answer be? Let's do how many 5-digit numbers, 5-digit numbers without replacement. This is just to brush up.
5
5-digit
factorial.
number. Yeah. So you have 5 options in the beginning. So there are 5 steps to do a 5-digit number. So you will have to do you have 5 options. Once you select that number, you have 4 options now. And you have 3 options next and 2 options left and then 1 option left. So, and since this each step is dependent on the previous step, you will have a multiplication of these numbers. Just so it should be 5 factorial. That is the multiplication of 1 to 5, and that is 120. Again, if you were asked how many 4-digit numbers with unique numbers can you make, what would be your answer? So this is what. So this is called a. Yeah, go ahead. Can anyone tell me how many 4-digit numbers? Yeah, bro, Mujit, go ahead.
4 factorial into 2.
So 4 factorial into 2. No, I'm telling not the answer of this question. I'm telling what would be the number of 4-digit numbers you can make, or from any 4-digit number.
5 choose 4 into 4 factorial.
Correct. So this is, but I will not directly say what is choose 2 and so on. So let us see what is that concept. So you have how many options do you have? You have 5 options, 4 options, 3 options, and 2 options, right? So it is equivalent to writing 5 into 4 into 3 into 2. So you don't have to take the 5th one. So you multiply 1 and divide by 1. So in this case, so it would be like easier to understand if you had 3 digits, then you would have stopped here and then you could have multiplied the numerator and denominator by the same number. Say let's take 3 digit. Then it would have been simpler. So for the definition's sake. So 5 into 4 into 3. So 2 into 1 I'll multiply and 2 into 1 I'll divide. So this numerator is a 5 factorial and denominator is 2 factorial. So this is also known as a permutation. 5 P2 or 5P3, whatever. So this is defined as n factorial by, so 5npk is defined by n factorial by n minus k factorial, or by k factorial. So just a second, yeah, n minus k factorial. So there is something also known as, so if these orders did not matter, what would happen? As in, if these numbers were same, for example, you had 2 5s and so on. So for example, you had 2 5s in this. So I'll give you an example. Say a number exists 5 5 4 1. So how many permutations of this number are possible? So if you are asking how many ways can you shuffle the numbers around? So as in many of you have told me, it will be 4 factorial first. But do you see there's a problem when there is repetition, or you have to select when there is a repetition, you see 5 and 5, and if you reverse the swap between 5 and 5, they will be different. They will be the same configuration. So you may have to divide by the repetition factorial, that is here 2 factorial here. All right. So in general, if you are told in how many ways can you select k objects from n objects, then what would be your answer, such that the order of selection does not matter? Selection does not matter. It is akin to this 5, 5, where the order did not matter. So in that case, it is defined as a combination, as Brahmujit was referring to. So what do you mean? In how many ways can you select k objects from n objects, such that, so you tell me how many options do I have when I start off? I have to select k objects, right? I have to select k of them. So I have n options, right, in the beginning. Agreed? 1, 2, dot, 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 k. Agreed? Once I've selected the first number, say I have 1, 2, 3, 4, dot, 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 n, all these numbers, such that you form a set of these numbers and not numbers of these numbers. So then how many ways can you select the second number? N minus 1 ways. I hope these are becoming very fundamental, so that's why you're not talking. So then you have n minus 2 ways, and at the end you have n minus k plus 1 ways, right? So which is equivalent to saying you have n factorial by n minus. So you agree that you can multiply. So n into n minus 1 dot 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 n minus k plus 1. Then you can do n minus k minus 1 dot 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 1. That is n minus k factorial. So that is n factorial by n minus k factorial. Ways you can, these many numbers you can make, but do you see that you're overcounting? Since this is a set that you're making, the order of these numbers do not matter. So how many factorial ways can you, how many over factorial ways are you over calculating this?
K factorial.
K factorial ways.
Okay.
So you divide by, yeah, go ahead. You have a question? Okay. So this is n fact, this is defined as n choose k that we'll be using. So in our course and anywhere we'll not be using permutations. So as Brahmujit was telling me, we will only be using combinations. As in how, what does that mean? So he told me how many ways can you select 4 factorial of these numbers, right? He told me how many ways can you select 4 of these 5 numbers. Hope yeah, I'm online. So he was telling me he's a 5 choose k into 5 factor 5, right? So he was telling into 4 factorial. So that's what I'll be showing you now. So in the case I was telling you to make, say, 4 numbers or 3 numbers here, 3-digit numbers. So as Brahmajit was telling me, it is how many ways can you select 3 numbers from 5 numbers. So you selected 5 of those numbers, so you make a set. And then what are the other numbers that you will get? What are the other numbers? I hope I'm audible. There's a network issue over here. Yeah.
Can you repeat the question?
So for time being, I will be forgetting about the number of ways and multiplication rules and so on. So I'll be just talking in terms of choosing things, right? I'll not be talking about permutations throughout this course and throughout probability or counting. So that's why I'm saying how many ways can you select? So if you're told to make 3-digit numbers, so what would be the steps if you are told to use combinations? That's the question. So if you're told to first choose and then permute, that's the idea.
You can do 5c3 into 3 factorial.
Correct. So exactly that's the idea. So you first select the first 3 numbers, and then so once you selected the first 3 numbers, you can permute all of them in any order you want. So you get, this will turn out to be 5 factorial by 3 factorial into 2 factorial. So this is all I wanted to revise. So in case I have been told that there are a few people here from there are people here from my lab as well, the research assistants here who have a bit of a couple of people who have a biology background. So for them, I'm just revising what are factorials, and I know you all are very familiar because you're from mathematics background. Anyways, so that's enough with revision. So first, the ways you can select things is by combination. This is called a combination, right? So could you please switch off your videos in case you're not speaking, because in that case I'll not be able to. I don't know what is happening. Yeah. So I'll be using these combinations once again. and I'll see if I can solve this first question. So someone of you, I think Bromodi, already told me the answer to this question. So let's me solve this question now. So the question is, how many 4-digit numbers can you make out of these numbers? So 1, 3, 4, 7, and 6, I guess. Yeah. Does that it is divisible by 3. So what is the catch here? Has to be divisible by 3, right? So how can you make a number divisible by 3 from your primary school ideas?
The sum of the digits
Digits
would be
should be divisible. Yeah, very good. So what are the sum? So you have to make 4-digit number. So let us try to solve this. So what is the sum of all these digits? 1 plus 3 plus 4, 8, 15, 21, right?
Yes, yes.
So which is equivalent to 0 mod 3. So it's divisible by 3, right? It's not, there's no issue. So if it is already divisible by 3, I have to select 4 numbers from these. So when you end up selecting 4 numbers, what is it essentially? It is essentially removing 1 number from this set, right?
Yes.
Okay, anyone else? So if you have to select 4 numbers, you can see it is equivalent to removing 1 number out of 5, because you have to select 4 out of 5. I think that's trivial. So which of these 2 numbers, if you remove, will still keep the sum divisible by 3? That's my question.
3 or 6.
Yes. So there's only 2 numbers that are divisible by 3 here, -3 or -6. You have to subtract these 2. So you leave these 2 other numbers that you can leave out. The rest of the 3 numbers have to always be there, right? So then, so how many ways can you make this number? So you have 4-digit numbers, right? So you have 4. So you will have for each time. So now you see the second case is coming up, right? So first case where you removed 3. So are you seeing how I'm using the addition rule? So I use multiplication rule now. I'm using the addition rule now. Case 1, they have to be exclusive. Remember that, and independent. Case 2, remove 3. So I will be left with 1, 4, 6, 7. 1, 4, 7, 6, whatever. And I can permute this into 4 factorial ways. Agreed? Similarly, if I remove 6, I will again be able to permute it in 4 factorial ways. Yes or no?
Yes.
Okay, very good. So, but anyway, so yeah, I hope this is very clear. And if you have any doubts, you ask. Otherwise, I'll be moving on to the next part. So it's 4 factorial into 2 ways or 48 ways you can permute it. Correct.
What if
so
the original number was not divisible by 3?
then you will have to accordingly make up, right? So all the cases you can make up, see which number you have to make 5 cases, right? Then
I'll have to make it case wise then.
yeah, again, you will have to see case wise and see subsets and so on. I think you would not be given, then slowly it will become a very hard problem to solve, because you'll have to see all combinations. That's not the idea. So idea is to see if you know the dividing into cases and know how to permute numbers and use combinations, right? Understood?
Yes, Mayanta.
Yes, brother.
Very nice. So let us do one simple question, and then I'll be like, I had done this question, but I end up loving this question very much. This is one of the favorite questions of mine. But anyways, let us try. The question is, how many ways can you select k or k objects, right? So what was the, yeah, from n types of objects, from n types of objects, with replacement, as in if you select the first object, so I'll give you an example with replacement such that order of selection does not matter. Right? We had made a table last time. You can refer to that video beginning, but this is just the most difficult version of those problems. So I have ended up doing all the other versions anyways by explaining. So what does that mean? So if you have n objects, so you have a ball, different type of balls, right? Say ball 1, ball 2, and you have ball n, right? And how many balls do you have to select from these? You have to select k balls. Do you agree?
Yes.
Right? Or in parts of it, you can ask. So each of these ball types have infinite supply, or you can, once you select one ball, you can reselect it again. So you have the option of reselecting it again. So any questions regarding how many you can choose? Yeah. Did you
So,
understand? Yeah, go ahead.
Do we have to choose at least one from each type?
No, there's
Okay.
you have to just select k objects. If you have to select one, I'll be to be told. Did everyone understand the question except Partho?
Yes, Daniel.
So you have to select.
Yes.
So it's as yes. So if you have k balls with infinite supply, each identical. For example, if you have red balls infinite supply, green balls infinite supply, and you are told to make a bag of k balls, right? So you can end up selecting each of these subtype of balls any number of time you want, right? Any finite number of times. That's the thing. So I am going to mark it as tallies or dots here, right? Say I selected 2 times, I select this 1 time, I select this 3 times. Agreed? So that the sum, it sums up to k. Do you agree? I hope you understand.
Yes.
So it is also equivalent to writing x1, or say let's write b1 plus b2 dot 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 bn is equal to k. Do you agree? Bi being the number of balls selected for a particular type.
Then I'll have to find the number of solutions of this equation.
Yes. For the particular type. But there's a very simple way to find the solution of this equation. Bi being the number of balls for a particular type I. There's a very simple solution to this set of equations. You don't need to solve all the combinations and see how many you can make. You don't need to solve a multinomial problem here. How can you do that? It's a very nice way you can try that out. So do you agree that permutations within these are within each of these, say bn, I'm circling this bn. I think there's a lag from my tablet end, so please bear with me and hear me carefully. So this circle that I've put here, do you agree that permutations within these are immaterial? Yes or no? Like it's not important to do
Yes,
permutations
because
there.
they're indistinguishable, I
Yes, my
guess.
Yes, very good. So it's accordingly you can like select. So you can now even forget the identity of these balls. And say you have these and you have some demarcation like this. Do you agree? So how many demarcations do you need to divide it into k bins?
n minus 1.
K
Very good.
minus 1.
K minus 1. 1, 2, dot, 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 k minus 1. This is region 1, 2, 3, and k. Very good. So how many objects are here now? So do you agree if I permute these objects now, I will get all the solutions?
K minus 1
Right?
factorial.
Why k minus 1 then?
N plus k minus 1 factorial ways I can permute these. Do you agree?
Oh,
How
yes.
many objects are there? There are k balls. How many balls? K balls? Or how many n balls? Or how many? I forgot. No. This is n minus 1 balls, right?
Yes.
So I'm dividing into n groups, not k groups, right? The number of balls would be k. 1, 2, 3, and this is the kth ball. Isn't it? How many groups am I dividing it into? N groups? Isn't it? Like people who said k minus 1 factorial, did you understand? Like
Yes.
why am I writing like n minus 1 and not k minus 1? Because k
Yes.
minus 1, n minus 1 boundaries will help me to divide it into n regions, as I have pointed in this figure. So there are n minus n plus k. So there are how many objects? There are n minus 1 bats and k balls. Right? Very good. So how many objects are there? There are n plus n minus n plus k minus 1 objects. So tell me, are all these combinations unique combinations?
No, those of which are part of the same component, those permutations will not be
Exactly.
counted, right?
Exactly. So I can permute these two amongst themselves, but they're the same number, right? So in how many ways can I permute the bats? I can permute them in n minus 1 ways. So I have to divide that by the number of permutations I can do with the bat, keeping the balls constant, right?
1 second, please. That how did the total number of objects become n plus a k minus 1? Could you please explain
How
again?
many balls do you have? How many balls do you need to select?
K balls.
So there are k dots over here. Do you agree?
Yes.
So how many demarcations do you need to separate it into n groups?
N minus 1.
Correct. So how many objects do you have now? So I've written it already. So n minus 1 bats and k balls. So how many objects do you have now?
It's n minus 1 plus. Okay, it's n plus k minus 1. So why
Correct.
are we
And now do you agree that if I swap around the bats and balls in any order, I'll get all the combinations of the solutions to that equation?
swap the bats and balls in any order? Yes.
Any order. I
Yes.
can. But I'll
Yes.
be overcounting because permutations of the bats amongst themselves and permutations of the balls among themselves are essentially the same combination, essentially the same configuration. Do you agree? Like
Permutation of the bats among themselves and the balls among. No, I didn't understand this part. At the same, since permutation among bats and balls are the same configuration, I didn't understand this part.
so if they are the same configuration, say I have b ways of doing a same thing, right?
Yes.
And out of those b ways, for every k ways, I am selecting all the combinations again and again, right? So for k ways, out of those b ways, I have repetitions. So how many unique numbers are there? It's the unitary method, man. It's
Okay.
b by k, right?
E by k.
So keeping the balls constant, you can move the bats around, but you will have the same configuration. Do you agree? And you have already moved that when you have taken the numerator. It's the same
Yes.
way I derived combination formula. And similarly, when you have same objects, that's why you divide by the number of same objects. It's like class 11 combinations question. Yes or
It's
no?
more like the two bats are swiping each other, which
So
is
you have
essentially the
k.
same, right?
Yeah, the balls are also the same, right, Partho?
Um. Yes. The means the balls can permute as well as the bats. So by n minus
Yes,
1 factorial and then k factorial. Yes, it's clear.
correct. So anytime you have similar type of objects, so these you have to think as sampling. So every time you're putting these 1 1 1, these are some tally marks, so they are identical. So each of one of them, you can permute in any order, it doesn't change anything. So anytime you have groups, you can permute n ways, n factorial ways, and if you have groups of gi, so the formula is n factorial by g1 factorial into g2 factorial into gk factorial, such that k1 g1 plus g2 dot 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 gk is equal to n. This is the formula that you always used in school, right? If you have groups of say 5 tables and 6 chairs, how many ways can you permute them if they were identical? It was 11 factorial by 6 factorial into 5 factorial. I hope that is clear. So what is this turning out to be? N plus k minus 1, choose k. Yes or no?
Yes.
This is one of the most fundamental ways of choosing or solving equations. So in case you have to select one, you can add one to each and like change these things accordingly. I may give that as a homework problem. Anyways, so we are warmed up with calculations. We have seen permutation, combinations, number of ways to handle them, and we have understood what is the how many ways can we select things and how to count number of ways you can do a thing. And with that, let us begin let us build on these concepts a little bit more. So what do? I'll give you an idea what is called story proofs. This will help you better think about problems in terms of permutations and combinations. So first question is, can you give me a story? So this question can be solved easily by 1 plus x to the power m and 1 plus x to the power n is equal to 1 plus x to the power m plus n. By using the binomial theorem, you can see the kth coefficient of the kth root coefficient of kth x to the power k and a coefficient of x to the power k on both sides and equate them, and you will get this answer. Do you agree? I think there's nothing to agree. You just need to do the algebra. Do you understand binomial theorem? If you use, you will be able to do it.
Yes, means in each of the polynomials, the same exponent terms are being
Exactly, the
multiplied.
coefficient of the kth exponent. But I will not be doing this. Is class 11 mathematics. These things I don't do now. Now I have to think in terms of probability and not think in terms of algebra. Thinking in terms of algebra, gone are those days. Tell me, how do you think in terms of probability? People who have attended my previous course, they should be able to tell me, how do you think in terms of probability, and how can you devise a story just by argument's sake? How can you prove that statement? I don't want any math. I just want arguments to show that both sides are equal. Can anyone tell me?
Can you please
I'm
show
taking
the formula
Yeah,
once?
go ahead.
So if you're asked like if you pose a question like you have to choose k objects from m plus n
Okay.
objects where we have m objects of one type and n objects of one type,
Brilliant. That's great,
then we
Hussein.
can.
Yeah. So what should I call you? Should I call you Farshid or Hussein?
No, I am Ashmit.
No,
Oh,
that
you're
was not me. I was going to say that, but
Ashmit. Ashmit, yeah, Ashmit, tell me.
Yes, so if we consider m objects of one type and n objects of one type, and we want to pick total k objects, then the simple answer is m plus n choose k,
Correct.
and then we can break it in terms of like we choose 0 objects of m type and p object, k objects of first type plus one object of m type.
Brilliant. That's a brilliant formulation. Exactly, but I'll make it a bit more interesting and write it down. Say you have to make a committee of, just to make it a more better story of the absolutely, you get full marks for that. I would not even think. Let's make it more interesting for others. So you have a committee of, yeah, of k people to make. Right? You have to make a committee of k people. There are m men and n women. in contention. So how many ways? Let us for the time being take m and n. So whatever, say m plus n is greater than k, right? Let's take that. Let's for the time being believe that there are more men and women such that both have greater number of greater than k. Whatever, both m and n are greater than or equal to k. So how many ways can I select? So I can select, as Ashmit was telling me, select k people without thinking about who is a man or who is a woman, and just select them randomly based on some ID, right? Do you agree? Without considering their sex. I don't consider what is their sex, and I just select k of the m plus n objects. What is the other way? Where again, it's a division into cases, as many of you I showed you in the previous question. What are the cases? As Ashmit was telling me, case 1 would be k women, 0 men. In how many ways can you select that? Anyone?
So
Well,
I will choose m choose k and n choose 0.
Yeah, very good. So let's say I've written p women and k minus p men. How many ways? N choose p.
So it's n
And
choose p, n choose k minus p.
very good. So it will be all these combinations that you agree these are all exclusive combinations. So you will get summation of n choose p, m choose k minus p. P ranging from 0 to k. Is that okay? Did everyone get the idea? I hope you did. Anyways, the second question, how do I do? Telling me, yeah, go ahead.
So if I have n plus 1 objects and I have to select k plus 1 out of them, let's say I have n plus 1 eggs and I need to select k plus 1 out of them, and there is one rotten egg. So, so I can either take the rotten egg or I can't.
Very good, very understood. Very good. You have understood the concept. So correct, understood. So there are, say, n plus 1 objects. So for example, let us take, you have to make a team of k players, and there are n players in contention. N players in contention, and you have one selector, right? And just a caveat, it shouldn't be there's conflict or interest here, but just for interesting, say it's a college team and the selector is a player himself or herself. What will he or she do? Maybe she comes up and tells, "Ki, I will play and I will select k out of the other k other players." Or she may come up and say, "I can select k plus 1 players, right? And I'll not play myself." Did you understand? Select. So one selector, they select themselves. Case 1. So how many ways can you select? So how many players left? K players left. So it's n choose k ways. Similarly, they don't select themselves. How many ways? N choose k plus 1. Do you agree? Because they have not chosen themselves, there are only n people left. And you can make a team of n plus 1 choose k plus 1, choosing from all these people, which is equivalent, right? Any way you want to choose. Right? Is it okay? Go ahead, ask questions if you have any doubt.
This was clear, Monica.
Okay. Anyone else? Then we'll go and begin with probability. I'll just wait for 1 minute, and then if you have any doubts regarding counting, so this is just a recap of counting should be like in your fingertips by now. We'll be beginning with probability, which you had all this while being doing as number of favorable outcomes by number of total outcomes. But now I'll just give you a different perspective, a little bit of a different perspective. There's also a very, very large detailed course on this. I have done it last time, which does touch upon what is sigma fields, what are sigma algebras, and so on. I would not go into those this time. I'll be taking a more of a computational approach, because people are also there. A lot of people from first year this time. I would not want them to burden with a lot of set theory notations. But if you are really interested, you can go and look back at my previous course. I'll be putting it in the description also of this video on YouTube, and also on the Teams link. I'll put it up. In any case, if you want to, you can look it up. But before we get into all these, let's see what have you been. I'll not show this now. What have you been doing for this time being? You have been telling me the number of favorable outcomes by total number of possible outcomes was your probability of an event, right? Say, what is the probability of head in a coin toss? So you to tell me there are two outcomes in a coin toss, head and tail. It is according to class 11, 12 probability. I'm not going into anything. I'm just giving you a recap, your story. So you would tell me there are two options, the size of the sample space, that is one head and tail, and you have number of favorable outcomes. How many favorable outcomes here of a head is 1. So 1 out of 2, what's your probability of head? Did you remember? I think let's do one question, it will be clear. And then I can get back into probability. I'll just warm you up into this. Yeah. So this is also a gate question from this time. So 3 coins are tossed independently. T is an event where 2 or more heads occur, and S is an event where 2 or more tails occur. Okay. So first tell me how many total cases are possible. So number of possible outcomes. Again, this has to do with counting.
Yes.
How many total? Yes, that's why I'm saying we started off with counting.
It is 8.
8. Why?
2
So this is
cube
another.
means 2 for
Why
each.
2 cube? Why 2 cube?
2 for each coin. So since
Okay.
every
So you have to do 3
farming
tosses.
system,
You have 2 option, 2 option, and 2 option. So without repetition, there is options, or rather n options each, and you need to select k. You need to make k observations or k outcomes using them. You can have n to the power k ways of selecting them, right? You have n options, n options, n options for k times. Agreed? Here also, you will have 2 to the power 3. Do you agree? Head, 2 options for the first toss, 2 options for the second toss, and 2 options for the third toss. Do you agree? This is all the possible outcomes. So what is the event T? Event T tells me when 2 or more heads occur. So how many, what is the size of what are the elements of T? They are head, 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 tail, head, head, tail, head, tail, head, and tail, head, head. Do you agree? Anyone? Good. This is simple only. So
yes.
2 or more tails appearing, it's tail, tail, head, tail, and tail, tail, head, tail, tail. Right? These are the 4 options. of 2 or more tails occurring. So what is the probability that T intersection S occurs? It's nothing but phi, right? Yes or no? There's no outcome favorable for this probability, right? Okay. So what would be the probability of S intersection T?
0.
0 by 8. So what formula did I use? Number of favorable outcomes. This is also known as the naive definition of probability. Total number of possible outcomes. This is the naive definition of probability that I'm using. So what can anyone tell me? What is the assumption that this naive method uses?
That all the
It use
outcomes are
yeah.
equally likely.
Exactly. So each of these outcomes are equally likely is what this definition of probability or the very, very naive definition of probability uses. So in case you would be told a biased coin is there, you will not get half as the output of your probability of head. You will maybe get 60% of the times you will get head. So this is very naive an approach. So do you understand how did we use counting and how did I use? So in case you haven't, I'll just wait for 1 minute and then I'll go get into what is probability correctly. All the while you have been just using the most simple and most naive way of sampling or weighing things equally, as Brahmajit is telling here. Right? So what are the problems of this naive approach? The problems of this naive approaches are, so we have done this. So what is the probability of jumping to moon? If I jump from the ground here, what is the probability I reach moon? If I use this definition of probability.
This is half. So either I reach or I don't reach.
So outcomes are reach or yes or no. And you reach or not reach, number of favor. What is the probability of reaching? Is half. You are doomed. Whoever gave you all these ideas of naive probability, you have to just throw it out of the window. You can't use it anymore. Wrong. So the probability of jumping to the moon is infinitesimally small. I'm not ruling out anything yet. It's almost surely 0, right? So yes would have a probability of 0, 1 would have a probability of 1. No would have a probability of 1 here. But since you have just counted number of outcomes by total number of outcomes, you're doomed. So how do you account for all these? So last time we had done a very detailed summary of how do you account for that using measure theory. But this time I'll not give you what is a measure theory, but I'll give you a broader intuition regarding this. So in case you're interested, you please go over the last time's videos. So for a random experiment to occur, there are a few things that you need to understand. That there are a set of possible outcomes, right? A set of possible outcomes that is defined by this sigma, right? This sigma is called the sample space. For a random experiment, what are the outcomes the random experiment can take? For example, throwing a die can take between 1 to 6. Throwing a coin can take between head and tail, and so on. So that defines the sample space. Now, an event space is defined as all the subsets of the sample space. We are not going, this is exactly not the right definition. The exact right definition is it's a sigma algebra over subsets of sample space. I'm just telling you in case if you are interested, you can go and look at it. That's the definition. But now, for now, we'll consider that all the subsets are equally available to you, right? So all the subsets are available for all our purposes for GATE or even for your UG courses. Until you get into masters and higher studies, you would not require probable like major theoretic definition of probability. It's enough to know, consider that you use all the possible subsets. So just a detour, how many subsets do you have for a set? It's a very favorite question of GATE. Like it has come many times. Even at JE, it has come many times. How many subsets can you make? So if you have a set sigma, where mod of sigma gives you number of examples, number of elements in sigma. How many? So F is a subset of subsets, set of all subsets of sigma.
2 to the power mod sigma.
Yeah. Can you give me the idea, Ashmit?
Like we can either take one element or not take an element. So we have two choices for each element. If you just multiply that.
Very good. Very good. Very nice. So for others who did not understand, I'll repeat what he said. So a set can have 1, 2, ... mod element 1, element 2, and element number mod sigma here. They're all present. So for if you want to make a subset, how many ways can you make a subset? You can either select one element. There are two options, right? Yes, select, or not select to make a subset. So there are two options for each. So you have 2 into 2 into 2 into 2 into sigma times. So you have 2 to the power sigma options. So this is a subset. This is the size of the 2 to the power mod sigma is the size of all the subsets of F, which consists of all the subsets, right? I get you understand. Let us look at this question and you'll understand then. Like there are two coin tosses. What is the sample space and what is the yeah, that's stuck for a bit. But anyways, what is the sample space and what is the event space? So remember, event space is a set of all subsets of the sample space for our definition. Okay, so what is sample space here for two coin tosses? I'll just ask any one of you now. Anyone?
Moinanta, your audio is cutting out a bit.
Is it okay now? I think there was some network issue. Is it okay? Oh, I think there is a bit.
Now.
I think it will be.
You have been muted.
I think Moinanta has been disconnected.
I am not audible.
Voice is not audible. Video is steady up.
Hello.
Yes, now it's audible.
Yes, Moinanta.
Great.
Audible.
I think there's some. I think I'm audible now, right?
Yes, Moinanta.
Clear, right? In case you find any difficult, because this is being recorded, right? If it is not recorded properly, it's waste of all the resources, our time, and because we want people to have a look at it afterwards as well. So in that way, please, thank you for being for helping me out. Keep helping me. Otherwise, it's very difficult to do online classes like this. Yeah. So what would be the size of the sample space here? What would be the sample space itself? If you're told to find the set of all the possible outcomes of two coin tosses. Go ahead.
So it'll be HH, HT, TH, TT.
Correct. Similarly, what would be the event space now? So let me start off. So when I select nothing, so this is one
Fine.
element, right? Fine. Then what would be one? Let me take subsets of one. Head, head, tail, tail, head, and tail, tail. Right? I hope it is clear. Now two at a time. Is it clear? And then three at a time. Head, 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 tail, tail, head, tail, head, and tail, tail. And then the entire set. Do you see 16 elements? So I have 4 plus 6 plus 1 plus 1 plus 3. Hello, am I not audible?
Oh, no, Monica, you're audible.
You're audible.
Okay, great. So there are groups of 3 here, and then there's this 4. So how many total are there? What is the total number? So 16, right? So 4. So when you select none, there can be 0, like one way of doing that. When you select all, one way of doing that, and so on. So 2, 1, if you select, there are 4 ways. 2, if you select, there are 6 ways, and you have 4 ways if you select 3, right? I think I did not write all the 4 ways. Head, head, tail, head, and tail, tail. And similarly, head, tail, I think I wrote that. Anyways, you get the point. So you have to select 3 numbers, 3 and then 2 and then 1 and 0. So you get all the subsets. Do you agree? Did you understand what is the sample space and what is the event space? Now we have we have left out the old definition of what is probability by number of favorable outcomes and by number of outcomes. And we have moved to the definition where you define a probability function over all the elements in the event space. So your probability space is a 3 tuple, which is a probability, which is a sample space, an event space, and a probability measure. So roughly speaking, a probability measure takes any element from F, that is any element from this event space, which is a subset of, do you remember? Any element from here, which is a subset of the sample space, right? And assigns a probability to that. Do you agree? So P is a function that takes any subset of the sample space, which are also elements of the event space, and assigns a probability to it. So in what way can you define it? You can define it as P being a map from the event space to 0, 1. Do you agree? The probability is between 0 and 1 always. 100% certainty is 1.
Yes.
Right?
Yes.
Good. So it's all elements. So if I ask any one of you, would be able to say that there is a sample space and there's subsets there which are part of the event space, and then all those elements are given a particular probability, right? So this is the proper definition of what is a sample space, event space, and a probability measure. So we have measured, you have given a probability function now, which tells you the probability of each of the events. Okay, so now for anything to hold, we need to define some things, right? So P is defined on events. So, but without any definition, we just know it's a function between events and 1 and 0 and 1, real numbers between 0 and 1. So what are the properties of the function? That will help us calculate probabilities. There are three important axioms. That is considered to be axioms, as in they're truths. They are not to be questioned.
Dada,
Yeah.
what's
Yeah,
the like significance of the event space? I mean, it's not. I mean, it's mathematically the subset of the sample space. But what does it actually mean? What does it mean that H comma H?
The last time I told, so each element, so how do you define a probability function from probability function to a space of 0 and 1? For that, you need to give in some inputs, right? For a function, you need some inputs. Do you agree?
Yes.
So if it is an input, the domain has to be something, right? Domain has to come from a set, right? Elements in the domain have to be a set. So how can you, without defining a set? So F is the domain of all those subsets, which is being mapped to 0, 1, right? So your mapping technique. So here you have subsets. Each of this belong to sigma. Each is being mapped to some element on the probability line, 0 and 1.
Right.
So
That's
just
the
to
PMF,
define,
right? Probability mass function.
depends. Probability mass functions, PDF, everything can be there. It can be depending on the type of distribution you are considering. It can, yeah. But generally speaking, there need not be all the sets. There can be subsets. And that's why, like we had discussed last time, you were there. What is a sigma algebra? That time it had to be unions must be bounded was the idea, but we'll not go into that. But let us, for here, everything is fine and beautiful. So axioms of probability of theta being equal to 0 is equal to 1. So so we need to define rules for using using this function, right? So the functions is, we do not know anything other than that, other than the domain and the codomain. So these three rules are, so this is the null set. Probability of null set or event is 0, right? So if there is nothing, that doesn't contain anything, the most sane way to assign probability to that is 0, right? And if you take the entire set, something will occur within that, yes or no? If you take an element, if you do a random experiment, they will always be in sigma, right? The outcome will always be in sigma. Do you agree? I do an experiment.
Yes. Yes, Mohammed.
E1 dot E sigma, they're always a part of sigma. So if I take the probability of the events of sigma, that is always equal to 1. Any event you do is always going to occur. The sigma will always occur. Similarly, if there are subsets which are independent, the union of them should be the sum of each probability. So that tells it's a linear function, right? So the union, it's a linear, they are mutually exclusive events, as in, this is also known as mutually exclusive events, such that say A, Y and A2 are mutually exclusive events. Therefore, A1 intersection A2 should be 5. This is definition of mutually exclusive events. Okay. So if it are mutually exclusive events, what is the intuition? So if you are taking this event also, this event also, and this event also, according to the Venn diagram, this should be the area of these three regions. Do you agree? Just trying to give insights into why these axioms are true. Do you understand? Are good assumptions to make. But like, let us see some properties that you can use. There are more extensive properties that I have proved before, but let us do some just for warm up and seeing axioms of probability, how they are useful. So number one, so probability of A complement is equal to 1 minus probability of A. How do you prove that? Always it's easy to draw a Venn diagram. If you can draw a Venn diagram, you can, I think, easily solve this question. So if you have a probability of, this is A, do you agree the rest of it will be A complement? Yes or no? Or A complement is defined as sigma minus A?
Yes.
Yes or no?
Yes.
Right? So by the third axiom, mutually axiom 3 I can use. So with axiom 3, anyone can tell me what will be the procedure? So what is the, how can I use axiom 3 over here? Yeah, Otrich, go ahead.
Axiom keep
Probability of A.
Yeah. So they are exclusive events, right? So I have
Yes.
removed A from sigma, exclusive events. So probability of A plus probability of
Sigma by A.
sigma without A. So this is also nothing but sigma. Now I can use the complete probability is equal to 1 and say probability of A complement is equal to 1 minus probability of A. Do you agree? These two are also exhaustive events, right? A and A complement. If I take the union of those two, it is equal to, by definition, it is equal to the total, to the entire sample space, right? I've removed A and I'm taking a union with A itself. Agreed?
Yes, Manavata.
Okay. So in that case, can you help me with this question of inclusion and exclusion? It says that the probability of sum of 1 to n events is given by sum of each probability minus the intersection of events plus the 3 at a time and 4 at a time and so on. How do I prove it? Can you tell me how do I start proving it? So whenever these type of things are there in advanced probability, go ahead, Partho.
So basically, I just first I see draw the Venn diagram for two events. If I
Okay.
say
I can't use Venn
A1
diagrams
and
directly. I can only use the axioms. And Venn diagrams can help you use the axioms, but you cannot use the Venn diagram directly. That's the idea.
okay.
Yeah. So right, you are right in some way. Do you agree P of A is equal to P of A if there is only one event? P of A1 is equal to P of N1 is equal to N equal to 1. Do you agree?
Yes.
Similarly, A1 union A2. Well, how can this be written as? This can be written as, if you
P
see
of
the Venn
A1.
diagram. Good. No, but you cannot write it directly like that. You have to write it in terms of the axioms. So I have one. This is where I'm trying to build in you the mathematical proof. What are the steps of mathematical proof? You can use only the given rules given to you and not obvious things. Even obvious things can't be used. You have to even prove obvious things. So you see 3 regions are there in this Venn diagram, right? I have to break it up into exclusive events, isn't it? That's what I have defined in axiom 3. Do you agree?
Yes.
So how can I break A1 union A2 into exclusive events? I can do A1 minus A1 intersection A2, right? Union A1 intersection A2, union A2 without A1 intersection A2, right?
Yes.
And intersection, I'm just cheating a little bit. I'm just telling you what is the definition of intersection directly, instead of just saying what is the A minus this and so on. I'm just saying X, not defining what is intersection. I'm just saying key intersection means what elements are present in both. Anyways, so I can write this as probability of A without A1 without A1 union A1 intersection A2 plus probability of A1 intersection A2 plus probability of A2 without A1 intersection A2, right? And we've already shown without means subtraction, right? The probabilities have to be subtracted by union bound. They're again exclusive events. So this is your homework. How will you show? You will do it. So probability of A without B, or rather, let's say A intersection B, right, is equal to probability of A minus probability of A intersection B. Try doing it using this rule. It's very simple. So do you see, I will just subtract these. So I'll get P of A1 plus P of A2 minus P of A1 intersection A2. Yes or no? Right? I get two minuses here, from one here, and I have one plus. Clear? Or do I need to show the previous step? I hope it is clear, right? So let it be true for K. For K terms. If I can show that it is true for K plus 1 as well, I'll be done, right? Because I've shown for the base case and I have also shown for every K and K plus 1. By the logic of induction, I'll be done. Yes or no? Any
Yes.
doubt? Good. So let's write it down. A1 union A2 AN plus 1. I have already taken it to be true for n terms. I'm taking it for, or rather K terms. I'm writing for K plus 1 terms. So how can I write this? I can use the definition of 2. How can I use that? So I can write this as A1 union A2 union dot 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 AK, right? Plus A1 AK plus 1 minus probability of A1 A2 AK intersection AK plus 1. Is this clear or not clear? Now I will ask someone of you, what am I writing? Tell me. Tell me, someone, what did I do in this case?
You just
How did
use that P of A union B.
No, I will tell who will write. Now I have people.
Dada,
Orko Broto will tell. Yeah, go ahead.
last step was not clear. Can you explain it again?
Means this step, right? Up to 2 was clear, right?
Yes, the last step, that union one.
This step.
A1 to AK, yes, this one.
So I am writing it is true for the kth equation where probability of A1 to AK is following this equation pattern, right? The union of A1 to AK follows this pattern of equation. Do you agree? I am believing that is true. Instead of I am just assuming it is true. Do you agree?
Okay.
And then I can write AK plus 1 as a union of two events, right? A1 to K and AK plus 1, right? Isn't it?
Yes.
This is event 1 just using commutative rule. Or rather here associativity. Associating the union. So I will take the first and then use the n equal to 2, which I've already proved over here. And then, so you get the first term from here, probability of AI equal to 1 to K plus 1, right? From this, and you have minus 2 at a time. How am I getting this? A1 intersection AJ and so on. I'm getting it from here. Do you agree?
Yes.
This term, I'm breaking it in terms of this equation. Star. Only term that is remaining with me is this term. How do I break that? What is A union B intersection C? Can anyone tell me? This will be useful. Do you agree that is also equal to A intersection C union A in B intersection C?
Yes.
Let us draw a Venn diagram.
De Morgan,
AB.
right?
Yes, De Morgan's rule. Just to explain. So A intersection B intersection C is the A union B intersection C is A, B, and C is this part. Similarly, A intersection C is this part and B intersection C is this part. So you take the union, it is right. So it's a De Morgan's rule I can use. So if I use this De Morgan's rule, I can break this probability of A1 as A1 intersection AK plus 1 union probability of A2 intersection AK plus 1. Do you see? Again, you have K plus 1 terms and you will be able to subtract all of this by the union bound, isn't it? You have K terms here, right? AK intersection AK plus 1 now.
Acha, Moinanta, one question.
Yeah. Go ahead, Siddharth.
You wrote A union B intersection C is equal to A union C union B intersection C. Should that not be A intersection C?
This one. Yeah, that's a typo. Writing mistake. True. I'm writing intersection here already. All are intersection only. So you see clearly you will be getting a summation over AI intersection AK plus 1, right? All the terms that were missing, all the combinations you already got, right?
Yes, Moinanta.
Very good. And then you can take 3 at a time and so on. Again, you will have to subtract the intersections. Same way, iteratively. You will continue. Did you understand the logic? You will keep on doing it forever to get this term. Similarly, there's a very similar induction proof which I'll be giving you as homework, which is also known as the union bound. This is a very nice proof. Again, you can use your use the just now as we use induction and prove it using the first 3 principles. Okay. This is called the union bound. Very useful in machine learning and so on. Don't try to prove it from inclusion exclusion. It will be a nightmare. Try to prove it independently, right? Like n equal to 2, n equal to k, n equal to k plus 1. It should be done in 3 steps. I have already done the most difficult version. And I have also got another homework for you. That is the derangement problem, where you have, I'll just give you a, so why am I giving this as a homework? Because I've already done it in the last course of mine. So I think you also have done it in some form or the other in your class 11 and 12 by trying to solve equations. But I want you to use inclusion exclusion over here. How do you use it? So the question.
Really choppy, so it's a bit difficult to follow.
Oh. Hello. Hello. Is it okay? Hello. Siddharth, can you hear me now?
Still a little choppy, but yes, it's all.
Yeah, it's breaking up.
Now, is it breaking because of network issue or you are having background noise?
Maybe network
It
issue.
feels like a network issue.
So it's breaking, or is it? Are you having some continuous, like a noise, DC noise behind you?
No, now it is fine. Now it is fine. Earlier it
The
was
problem.
breaking up.
I think it's the network here in Bangalore. It's a problem. So, anyways, I'll try to arrange for mobile data next time. I don't know, like I do face it when I take classes in the evening because people may be using the internet, the Wi-Fi all the time. So I'll try to arrange for mobile data. Today I don't have it, so I'll be up. Just bear with me. In case you can't hear, just the rest you could hear, right, Siddharth?
Yes, more or less I can follow. It's just that it's a little difficult to sometimes.
No, as in, yeah, I understand. So up to this part where we have discussed the inclusion exclusion, I hope that is okay. The only thing that I would like to bring into your attention is try to solve this question where we have say, and please, I have 3 groups in this Teams channel. If you have solved it, please share it with into the groups link. I may like once you get certificates and all, I could like give you bonus points for that. Like you may do it because it will be helpful for others also. It will entice discussion in the group and so on. So only few questions I'm giving, and you can that may help you revisit the previous videos and the sessions that we had done anyways. So here the question is something like this. So you have cards C1, C2, and CN. And you have envelopes E1, E2, and EN. The question says, how many ways can you, what is the probability that if you swap the or permute the cards into random envelopes, what is the probability none matches? So I would tell you to use inclusion exclusion to solve this issue. So what exclusion? How do you use inclusion exclusion? Sorry, inclusion exclusion. You have to use. I'll give you a hint. These events. AI is an event where the ith card matches the ith envelope. This is the hint that I'm giving you. Try to solve it. And it's already there in the previous times video. And it's going to be just application of inclusion exclusion. It's just try it once. And you do a slightly different version of this, which is also known as the birthday problem, which will like be a more of a combinations and probability question. So let's try. The birthday problem says that there are n people in a room, and what is the probability that at least 2 people have birthday on the same day? So at least 2 people have the birthday on the same day. We are the caveat being we are excluding 29th February and taking 1st March as their birthday. Anybody born on 29th February, and we are considering only 365 days in a year. So what would be the probability that anyone born on the what is the probability of 2 people sharing their birthdays? Any idea how we'll go about doing this?
1 by 365.
Yes and no. How like there are n people in a room. What is the probability that at least at least 2 people share their birthday? So 1 by 365 is the probability that you have your birthday on a particular day, right?
Yeah, so I misunderstood
Like
the question.
if you're on the if you're 2 people, then yes, the probability of sharing is 1 by 365. Correct. But if there are n people, what is the probability that at least 2 people share the birthdays? So it's got to do something with counting. I would like you to recall how do we do that?
Will it be 364 to n by 2 divided by 365 to the power n?
365 choose
n minus 2 divided by 365 to the power n minus 1.
Let us see. Let us see. Something like that, but let me check. So there are n people in a room, right? So if n is greater than 365, probability of the event, let us write it as E, that at least 2 people share their birthdays. Right? At least 2 people share their birthdays. Let E be the event that at least 2 people share their birthdays. Then the probability of E is equal to 1, right? If n is greater than 365. Yes or no?
Pigeonhole principle, I guess.
Very right. Very right. By the pigeonhole principle, at least someone has to. So if there are 365 boxes and there are 365 people, at least one of these holes must have one extra dot.
Yeah,
That's how
will
I
it
put
be
it.
1 minus 365 factorial by 365 to the power n?
1 minus 360. No. Yeah, something closer to that. 365 factorial by n minus k, something like that you said, or let us check. So tell me. So now if you have n less than k, that's a good try though. N less than 365. How do I do that? Less than equal to 365. So see, I have derived one formula just now. 1 minus probability of E complement. Remember, sometimes it's easier to solve the complement problem rather than the actual original problem, right? Like P of E being equal to 1 minus P of E complement, right? That is what we have solved just now. Agreed? So what is E complement? That no two people share their birthday. So how isn't that easier to solve? How many ways can you create like get n birthdays such that no one overlaps?
365 or choose n.
Choose n into these people and individuals are different, right? Into n factorial.
Yes, into n
So
factorial.
for example, I'll take the first person. I'll have n dates or 365 dates for that person, right? Whenever you're confused, do it from the first principle. For the first person, I have 365 options. For the second person, how many options do I have? 364 options to choose from. Yes or no? Right? For the second
Yes.
person, I have already selected one date. 363 options for the same third person. 362 options for the second person. And for the fourth person. And 365 minus n plus 1 for the nth person. Agreed? Yes or no? As Artho was telling me. So this does end up becoming 365 factorial by how many factorial? N factorial? This is the number of ways I can select E complement set. Yes or no? And total number of birthday combinations, how many are possible?
Um, 365 whole to the power n.
So these are the possible number of outcomes, favorable outcomes. So here you can use them because each of them are equal probability. And number of outcomes, the size of the sample space is 365 to the power of n. Do you agree? So the probability of event E is given by 1 minus 365 factorial by n factorial by 365 to the power n. Any doubts? It turns out it's an interesting thing. You can write a program to check this
Excuse
in
me,
Python.
Moinak
Yeah.
Wouldn't that EC be 365 factorial by 365 minus n factorial?
Sorry, I was writing in terms of choose. Sorry. Correct. Of course. Right? Is this right? Oh, it is exactly not right. I have to multiply it again. Let us do it. Like 365 factorial by 1, 2. No, it's correct, no? What is the issue? So I'll have 365 minus n. Minus n minus 1. Oh, you're saying it is 365 minus n factorial, right? That's what you're saying.
Yes. Yes, that
Understood.
one.
This is what you're saying. Ah, that is true. True. This is same as 365 choose n into n factorial, right?
Yes. Acha, saying from a purely combinatorial standpoint means why do we multiply this n factorial in order to
So you're choosing for
permute?
so I am here in this room. You are there. Brahmajit is there. Shankhudev is there. Otrij is there. Okay. You all of you are there, and then I assign one date of birthday to you. Say let that not be a birthday, but some other arbitrary date to each of you. Okay. And then do you agree that is equivalent to choosing n dates? Yes or no?
Yes.
Right. But then the date that I gave you, I could have also given Shankhudev, right?
Yes.
So then that's why you first choose and then permute among yourselves. That's why.
Okay. First I will choose and the second n factorial is how I distribute.
Permute amongst themselves. Yeah, permute among themselves.
Okay.
Be a bit careful when you are permuting and when you are choosing. When it's required to be permuted, you need to just understand from the setting. And that comes from practice. When you are repeating, when the order matters, you permute it. Order does not matter, you don't permute it. Okay. When you have an ordered set, a set versus an ordered list. In an ordered list, the order matters. So you need to permute it. In a set, the order does not matter. So any combination. So 11 players in any order is a team. But if you are putting a batting order out, there are 11 factorial ways you can put a batting order out, right? Isn't it? Correct.
Yes.
So if from 15 players, if you are told to put a batting order out, you will be putting 15 choose 11 into 11 factorial. Similarly, if you are told to just make a 11 pair of 11, you will just, I'm not writing all these things, just write it down. I just got this good example. So if you want to make a team of 11, just make 15 choose 11 because there the set does not matter. Anyways, write a program. I'll tell you if you are wanting to write some programs, try to write a program and see where this crosses 50%. And you can get the value of n. There's no closed form, right, for this. So you can see n at approximately 23 or 24. You will have 50% chance that you share a birthday. So in a very small room, you can have birthdays being shared. Why? It's very anti-intuitive, right? Between any two pairs of, but the anti-intuition is majorly because we are seeing 23 as a number. It's generally the number of combinations you're checking between number of pairs. So if you see 23C2, it's 23 into 22. That's around 200. That gives you around 50%. That's a way to think about it. Did you understand what I said? Why you are seeing like 23 out of 365 is so such a small probability, how it is giving you 50% probability. Like around 46 people, you get around 90% accuracy. Just try to write a code and see, right? Because you're all computer scientists. You should be able to write code and check, find the values of n and tell me kahan pe 50% where kothay 50% hocche, kothay 90% hocche, and so on, right? Agreed?
Dada, can you explain the reason once more?
Reason as in which reason?
Why it is giving the 50% value at 23?
Oh, you're trying to asking me what is the intuition? The intuition is that you're not comparing one person at a time, right? When you're saying 23 people, you are actually seeing 23 pairs of combination and checking if there is a similarity between them, right? Or are their birthdays similar? So if you see 23 C2, you have, what do you have? 23 into 22 by 2, right? So you have around
Yes.
200, 250, 260 people. So that is a fair comparison to make. Although that's not a right answer, but it's a rough estimate of the fair comparison to be made. Okay, so I am just about to end today's session with what is conditional probability. There are like a few questions over here, but I'll probably do them in today. It's not a big deal. So what is conditional took a bit of a time to start off with, but we can now breeze through these conditional probabilities and so on. So everything in machine learning is a Bayesian learning, as we all know. I'll just take 15 minutes of your time today because we started a bit late. I'll stop at 10:15 today and finish this off. Otherwise, we have to start from the main things tomorrow. I hope that is okay with all of you. So conditional probability, what is a conditional probability? In probability and in machine learning, what you'll be always doing is doing Bayesian theory. What is Bayes' rule? Bayes was a priest in the 15th, 16th century who told that you can only update beliefs based on what you see around you and your prior beliefs. So you have some prior beliefs and what you see all around you, collect data, and then you can say what you believe in. That is the posterior distribution. We'll come to all that when we go in due course of events. But for the time being, let's consider what is a job, what is a Bayesian rule, or what is a Bayesian probability or conditional probability. Let's look at that. First, for that, we need to understand what is conditional probability. So now we have been looking at events, right? So say two events are there, A and B. So probability A given B is known as a conditional probability of A given the event B has occurred. So say B has occurred. What is the probability of A? What would be your answer? Like B has already occurred. What can you make updates about your beliefs of probability of A occurring based on the probability that B has already occurred? So do you agree that event must lie somewhere here for it to be also occurring in A, as you already know that it has occurred in B? Yes or no? You know it has occurred in B, but now to occur in A,
Yes.
it has to occur in the intersection. So let us say that is the probability of A intersection B. But now that is not rescaled, right? So now it is told to you that B has already occurred. So your new sample space is B, right? This is your new sample space, B, and not A, and not the entire thing, right? So you need to rescale the probabilities. The proportionality is still there, but you need to rescale it. So it should be by B. Do you agree? So this comma means A intersection B. Okay. Did you understand, or is there anything I can help regarding this?
It was clear, Manata.
Good. So I hope it is the conditional probability. So the thing is more or less clear. Sorry for that. I think it's the network that is, my tablet is a bit off. Anyways, so we have defined what a conditional probability is. It's the probability of both A and B occurring. Probability that both A and B are occurring that we have seen just now. Okay. So the way to read it, as we have discussed, is what is the probability of A? Having said B has already occurred. So let me see if you've understood the concepts of conditional probability and exclusive events. So there's a law called law of total probability, which says that if you have the sample space that can be divided into mutually exclusive events, A1, A2, A3, AK. They're all mutually exclusive, that they do not contain each other. Now, there is an event A that occurs. Then the probability of A can be written as, do you agree that it is A intersection AI's for I equal to 1 to K? Just from the diagram here, for all of these would be independent events because A can be written as unions of A intersection AIs. Do you agree? Yes or no? Because AI
Yes.
others, if AIs can be written as an intersection, so if AIs are independent, do you agree that any element in the intersection of A and AI would be also exclusive from one another? This is also exclusive list of events. Yes or no?
Yes, sir.
Yes.
So good. So what is the probability of A? I take probability measure on both sides. Which rule will I use on the right hand side to get this? Which axiom?
Union bound, I guess.
No, not union bound, because these are not exclusive, right? This is axiom 3.
Third axiom. Third axiom.
Axiom 3, exclusive events axiom. So see, you're using axioms everywhere. Very good. So now it says that I can also write it in terms of expected probabilities. How can I write that? By the definition of probability of A comma AI is nothing but probability of A given AI has occurred into probability of AI. Yes or no? Agreed? By the definition of conditional probability.
Yes.
So I'm just replacing this as I equal to 1 to K probability of A given AI into why is it important? I'll show you in an example just now. Understood? I guess this is clear. I'm just rewriting. So an easy way to remember is whatever is given, you multiply that, you get the whatever is given that is in the denominator, sort of the like pseudo denominator. You can just multiply the probability of that to get the joint distribution. This is called the joint probability. Distribution will come to later. Okay. Now, very simple thing, independence. When one event does not give you any idea of the other, or probability of A given B is probability of A, that is called A and B is said to be independent. Don't mistake independent and exclusive events. This is a disclaimer. Why? Can anyone tell me if can exclusive events be independent? If they are not like phi, like if it is not a empty event or a trivial event, can exclusive events be independent? Just from the Venn diagram, you should be able to tell. People do mistake exclusivity for independence. That's why I'm saying they're different concepts.
If it is exclusive, then the probability should be 0.
Correct. Probability of A given B as B has already occurred is 0, right? Because this is probability of A intersection B by probability of B, which is phi, probability of phi, isn't it? This is mathematically also I'm showing, and also intuitively B has already occurred. There is no elements in A. How will A occur? No problem. No like chance of A occurring, right? Uthrich, isn't it?
Yes, Dada.
Good. Similarly, now I can use, this is called the same conditional probability rule to write the Bayes rule. So this is the Bayes rule. The Bayes rule says that you can change the conditioning. How can I change the conditioning? So do you agree P of B given A is A comma B by probability of A? Yes or no? This is what Bayes came up with from his conditional probability definition. You agree? Okay. So what can A and B be written? I can also write AB as yes or no? right? So this is called the likelihood. This is called the posterior. We'll come to that when machine learning. This is called the prior, your prior belief. You scale your posteriors according to the belief. And this is the evidence for a event A occurring. These are the terms that you will be being more familiar as I am talking about machine learning. But for the time being, we'll just look at it as any x and y can be changed as the conditioning vector, right? As and how it is required. For example, this Sally Clark's case. Is this clear? I think Bayes rule was there in class 12. So I think nobody has a doubt, right? Right. Let's do this question. It will be clear. This is the last question before I end. Like I had this and a gate question, and then we'll stop. So the Sally Clark's case tells that there were 2 babies that a mother had in the US, and both died at the same age, around 3-4 months. And police arrested their mother. And they were not twins as also. They were like siblings. The first child was born. They died. Second child was born. They died. The same range, same age. So the police took their mother to jail, and the evidence that was produced before the court was given innocence, that their mother is innocent. What is the probability of coincidental death? So as being lawyers, they were very poor mathematicians. They didn't know that genetics also has to be accounted for. So they took independence of the death. First mistake. But let us still take there is independence in genetics. And the probability of dying by chance at that age is 1 in 1,000. So 2 childs died. Therefore, the given innocence, the probability of coincidental death is 10 to 1 by 10 to the power 6. Do you agree? Are you finding the story interesting? Is anyone having any doubt?
Not as yet, Manaka.
Do you agree it is 10 to the 1 by 1 in 10 to the power 6 is the probability of coincidental death if she is innocent?
In case of independence, yes.
Yeah. But the lawyer gave her imprisonment for life because her probability of the coincidental death was 1 in 10 to the power 6. But the lawyers forgot the simple rule of law, that is innocent until proven guilty. That means innocence or guilty cannot be taken as a probability, and you have to prove innocence or being guilty, being innocent or being guilty. You have to prove that in any court of law. So they had forgotten that, and being poor mathematicians, they forgot everything. So can you point out the flaw here? So she was sentenced to life imprisonment, but she shouldn't have been. A paper later on saw this in media, and 2 statisticians went out and challenged this judgment in court, and the decision was reversed. Why was it?
Well, this is because the argument that was presented, it says that the woman is innocent given that the children have died. But it should be the other way around, right?
No. What is the probability of the death being coincidental? As in, if she is innocent, is what was being posed to the judge. But it should have been the other way around, right?
Given that the deaths have happened, she is innocent.
Correct. Given that the deaths have happened, she is innocent. Exactly. That's the probability. So in that case, do you agree? Now comes the question of beliefs that our Bay in the 1960s, 1600s have had it come up with, that you do not know what is the probability of innocence given the data or the death of coincidental death, but you do definitely know probability of coincidental death given innocence into probability of innocence. by probability of, tell me what will be? Let me write coincidental death at CD and innocence as I. Tell me. And denominator should be coincidental death. But I don't know what is the probability of coincidental death without the innocent condition. So what law of probability will I use? Law of total probability, right? Is this clear? If not, ask now. Is this clear? How did I get probability of coincidental death in terms of conditional probabilities? I have divided into two exclusive events, innocent and not innocent, right? Are they?
Yes, sir.
This law of total probability, breaking up into innocent exclusive events and then taking the conditional probabilities. So the probability that a mother is innocent of the death of their children is 1, tends to 1. It's 10 to the power minus 1 minus 10 to the power minus 100 maybe. In the, or if you take our population, it's 10 to the power minus 8 or 9. It's orders of magnitudes different. Right? It's billions population, maybe few hundred commit such heinous crimes, mothers. So this becomes 1 and this goes to 0. And this is, so this goes to 0 and you end up having this as almost 10 to 1 and very large numbers, isn't it? So this is where the Bayes rule comes into play. So whenever you go to a doctor, you see, whenever people see a scan of cancer, they do have to check the probability given the scan. What is the probability of cancer? And not cancer given the scan. Like given the scan, cancer has happened, because the probability of cancer happening is very low. You have to account for the total statistics in the world to do proper probability. Okay. With that, let's do the gate question and then we'll call it a day. I have a couple of interesting questions. This Monty Hall also I had done last time. This is a homework for you. And you can just try this out. It's also there in my previous video. You can just check it out once or try it yourself. It's a very simple problem. It's a paradox. Try it out and entice discussion. So the question this time that came in gate was probability. There are 5 events u, v, x, w, and y. And it is given to be u, v, w, y, x given. And these are the terms that are given. So you have to tell which of the following is false. X is conditionally independent of u given w. Similarly, x and y are conditionally independent of y, and so on. Let's see which of them are true and false. How do you do it? Again, conditional probability. How do you agree? I can write u, v, w, x, y as, what can I write this as? See, I have this term. This can give me some insights into how do I break these terms out. How do you think I can break that terms out? Let's check. So I can break these terms out as, do you agree? I can write px comma y given u, v, w into probability of u, v, w. And you may ask, how am I breaking this up? This comes from practice. You have to practice breaking these things up into probabilities. Do you agree? You can break this up like this. Why is everyone quiet? Is it not clear?
Is y is that last term p of y given
Given
w?
w. Yes.
Oh, yes, because it's basically I guess the most dependents and such that the
I am just using chain like the conditional probability rule, right? A given B into probability of B. Yes or no?
yes, yes,
Correct.
yes.
And this again, I'll use conditional probability rule. So this term, I'll get this term. See, probability of W given U comma V, and I'll get probability of UV. Yes or no? Right?
Yep.
And this has been told to be equal to, this has been told to be equal to P of X given U or W, P of Y given W, P of W given UV into probability UV. Now see, what can you say from these? So do you see that X, so X and Y are independent. So if W is given, X and Y are independent, then I can break this up like this. Do you agree? If they are conditionally independent given W, this is a true statement then. Did you understand what is the step that I did? Probability of X given UVW, probability of Y given UVW. So conditionally independent means you can just break these terms independently of the denominator of the conditioning variables, given the conditioning variables, right? So given W, these are independent. You can write this as just products, yes or no? Probability of A comma B can be written as probability A into probability B, right?
Means how are you means you're understanding that they're conditionally independent on W, since in the
Question it is
question they
given.
have split it up.
Yes, the question, the RHS, I'm seeing the RHS and equating them, the derivations and the right hand side. Okay.
Okay. Yes.
So the right hand side says that UV has to transfer to U and V. So U and V are independent. And you must remember, conditionally independent does not imply independent, and independent does not imply conditionally independent. This is another homework. You can give examples and you can take a die and see. Conditional independence does not imply independence. Put a die, convert it into sets of 3 and see the intersections. It does not imply, either does not. So you see, U and V is conditionally independent given W is a wrong statement. Similarly, this turned out to be P of X given W, and this turned out to be P of Y given W, which means X, this is not dependent on these variables U and V. That is, X is independent of U given W. W is given, you don't need the conditions of U, right? So this is the correct statement, this is the correct statement. Similarly, Y is not dependent on V given W. Did you understand? Is this clear? I hope that makes sense, right? If you have a doubt, please ask.
Dada, what is the condition of conditional independence?
Okay, good question to ask. I mean, have not have. So conditional independence is probability that two events occur given a third event is nothing but probability of A occurring given C into same rule. There's no difference. Okay. Conditional independence means that A and B are independent given C. As in, if you write this as probability of A, B, C, probability of C, by probability of C, this is essentially writing probability of, where is it? A given C. So you can also write A given B comma C into probability of B comma C, right? Do you agree? Utkarsh? The numerator, I'm just again using conditional probability. Is it okay?
Yes.
Any number of terms you can select, condition that with that, and multiply the probability of that. So now do you see if A and B are conditionally independent given C? C is given, so they are independent. So B is no longer needed to infer A. This is the idea. So if C gives you all the information about A, the probability of A, B is just a, it is not going to give you any more information. That's the idea of conditional independence. So this turns out to be probability of A given C, and you have B comma C by probability of C, which is probability of A given C into probability of B given C. Did you understand the question and the condition? Yeah.
Means over here you are saying that C gives all the information about A, since that since A comma B given C is being split up into P of A such that C and P of B such that C. So in this case, I can say that C helps me to distinguish A and B completely from each other. So it
given C, A and B completely, the events become independent.
Okay.
I can give you an example also. Say you have a die, roll of a die, right?
Yes.
You have a roll of a die, A, B, and C. Let me just cook up an example. 1, 2, B is 2, 3, and C is 2. Give me one moment. Let me just check if this works. Probability of C is 3. Anyways, I'll just give you this idea. C has occurred. Do this gambler's losing question next class, and we'll start off. Or I'll just post it. Anyways, let's check. So A is an event. Say you have a die. What is the sample space? 5, 6, right? This is the event sample space. Oh my god, this is stuck.
Why are not audible?
Hello?
Your video is lagging very much.
I know. I can see that. Anyways, so I'm writing that. Yeah, I understand. I'll look at this next time. I'll just put. I'll look at it. I think that it's the confusion. This is the problem with the tab and so on. Just give me a moment. Yeah, I guess now you will be able to see. Okay. So what I'll do is I'll I'll just because I'm losing time, I'll just cook this example up quickly and stop this session. So 1, 2, so 2, 3, and C is say C is think about it. So I need 3 and so on. 2, 4, 6, and 1 and 4. I had copied this very good. I have kept it ready also. So do you see the probability of A and B occurring, given C occurred, is what? A intersection B intersection C? Tell me.
Yes.
Hmm.
No, I don't want yes. What is probability of A intersection B intersection C? Here?
1, 2, 4, 6. So it's 4
Just
by
2,
6.
right? Just. So here you have any do you have any intersections?
Okay.
Do you have any intersections?
No, there are no intersections. Means
Right?
no.
So this should be 0. Probability should be 0. Yes or no?
Yes.
Yes.
Which is not equal to probability of A given B, which is 1 by 6. Do you agree?
A given B.
C. A given C and B given C. That's what we are trying to prove. That conditional probability is not same as absolute probability. Even if there are absolutely probable, absolute probability is there, they may not be conditionally having equal probability, right? So for example, A given C is how much? It's just probability of 1, right? By what is the probability of A given C and probability of B given C? It is of course not 0, right? A intersection C by probability of C into probability of B intersection C by probability of B by C, right? Yes or no?
Moinagda is means is A the event that either 1 or 2 will fall?
Yes, it's just
Oh,
I've written it in terms of set. Yeah.
mm-hmm. Then it's
So 1 by 6 is the
1 by 6.
numerator and denominator is 1 by 3. Similarly, B comma C is 1 by 6 by 1 by 3. It is not equal to 0. Yes or no? I think it's stopped, but anyways, but you see the idea. But you see probability of A comma B. What is it? What is the probability of A intersection B?
1 by 6.
1 by 6. What is the probability of A?
2 by 6.
1 by 3. What is the probability of B? Half. So A and B are independent events, right? A and B are independent events. So 1 by 3 into 1 by 6. 1 by 3 into 1 by 2, which is also equal to probability of A intersection B. But
Yes.
But given C, they are not independent. So you can be independent given C. I'll give you a homework. Try to cook up an example where given C, they are independent, but not totally independent, but not unconditionally independent. This is a very important point to keep in mind, right? Now all the thing has come up. So you're seeing that conditional probability independence does not infer independence, and independence does not infer conditional independence. Do you agree?
Yes.
Both sides. I hope now
Yes.
you understood what is conditional. O3, do you understand what is conditional independence mean? How do you define the conditional independence? And if you don't, like last few minutes, you can just ask me. I'll stop it here. I'll not go into the gamblers doing problem today. I'll do it next day.
Yes, they are trying to understand, but there was a lag on the PDF you are
The rest
writing.
of the
So I'm seeing.
I know. Yeah. I'll go over the PDF if you want. So I have here tried to write the joint probability of A and B. Is it right? I still like point just see my pointer. I don't know if the pointer is where to show the pointer.
ভয়ঙ্কর ল্যাগ করছে মহিলাটা মানে video isn't there at times.
No, I understand. Like the video, the PDF is not coming. But my audio is coming, right?
Yes.
Yes, Dada.
I think, yeah, there's a problem with the Wi-Fi. Okay. So here I try to explain. So I don't know, like if it is, I'll just stop sharing this screen and just share from the laptop and finish it off. So just to explain. Yeah, I stopped sharing. Yeah. Now I have shared my screen. Can you see the screen now?
No, Dada.
You are? Or no?
No, Dada. Cannot see the screen.
No, video isn't up. We can't see the screen.
You can't. I've shared the screen.
Yes, now it came.
Yes, good. So what I wrote is this. So there are 3 events A, B, and C from a die. So 1 and 2 occurring, 2, 4, 6 occurring, and 1 and 4 occurring. So here what I'm trying to do is I'm trying to see the conditional probability of A and B occurring given C. Do you agree that is 0? A and B and C occurring is 0 in this case? Yes or no? It's the empty set. All the 3 events occurring. Yes or no?
Yes.
The intersection of all these 3 events are is phi, right? Okay. I think we are all exhausted, so it's okay. These events is if you take the intersection, there's no common element, so it's 0. Similarly, if I write A given B and A given C, I can write it as A intersection C by probability of C, and A intersection C is just this element 1 that has probability of 1 by 6, right? By probability of C, which has 1 by 3 probability, right? Which is not equal to 0. You can clearly see. So probability of A comma B given C is not equal to the product of the individual probabilities. But you see A and B have probability of 1 by 6 and A and B separately have 1 by 3 and 1 by 2 probability here. Which means that if you multiply A and B, probability of A into probability of B, which is equal to the joint probability, which means it is independent. So my argument being conditional independence does not show independence. And similarly, so I have already shown this. I've told you to give me an example for this. Right? Okay. I hope, I think there's a lot of issues now with the internet. I'll stop with that and have a look at the video and see. I think recording would be okay. Am I audible now?
Yes, Dada. Now you are
Yes.
audible. Video is clear.
Yes, now you're audible.
Yeah, okay. So what I said, so I tried look at the last part of it where I try to explain where conditional probability does not imply independence in probability, and independence in the independence in probability does not imply independence in conditional probability. I will share the PDF with you and the group and upload this video on YouTube. I think recording would be wise. It should be all right, and you should be able to look at the places you're missing. I'll try to fix this issue. This because I generally don't face this network issue this much, so I'll try to fix it. With that, I've not been able to do one question today. I'll stop recording. Yeah, so I've not been able to do one.